x-axis. Now we're going to label the increments for the y-axis, and this is going up by 0.5 kilometers. So this would be 1, 1.5, 2, and so on.
Miss Marsh.
Yes.
When's Christmas break?
So you guys will be here Monday the 20th, Tuesday the 21st, and Wednesday the 22nd. But then you don't come back until January 11th.
What?
It's like actually an extra long break.
We have like 16 days.
You have a lot of days off.
Do you guys not look at
Yes.
the school calendar?
No, they do not.
They what?
Bro, I have this stuff saved on my phone.
Me too. I have a
I used to
countdown.
have next year.
Do you have a countdown app?
No, I have like the actual school file.
Okay, yeah. I have a countdown app that tells me exactly how many days.
Oh, I used to have one because we were going on a cruise sometime.
Yeah.
I used to have one.
Gives you something to look forward to. Addison?
They don't have the school website.
When do we switch to our new DAs?
That will be January 11th.
Huh? Oh, I thought it was before.
We switched a week early.
I think, no, semester 2 ends that 22nd of, so that 9
Sure
weeks.
we go to our new DA that day.
Yeah, that Tuesday, the 11th of January, you will go to your new DAs.
And are you need that whole time?
Probably. Maybe not in this class.
Kind of nasty.
It's pretty
We'll
gross.
probably eat it for lunch.
Okay, let's go ahead and look at the scenario. In the first 8 minutes, he ran 1 kilometer. So I'm going to go over to 8 minutes and up to 1 and plot the point. So now I know he ran this far in the first 8 minutes, 1 kilometer. So I'm going to check that off. I've graphed that, it's done. He increased his pace and completed 3 kilometers over the next 16 minutes. So if he completed 3 kilometers in the next 16 minutes, how far has he actually gone?
20.
He's gone.
He's gone 4 kilometers. And what time will we be at? What's 8 plus 16? 24. So now we're up here. So he's going slightly faster, right? So not quite linear. Then he took a 10-minute break. So I'm going to go from 24 to where 34 would be and mark that as not moving, right? I don't know what the best angle is for this here. Just going to have a straight line. He's just chilling. Maybe he got a cramp. Maybe he's rehydrating. Maybe he needs to find the new song to listen to on Spotify, whatever. Hey, some of you scroll for hours looking for the perfect song. So let's not judge Mark here. All right, and then he finished a distance of 5 kilometers during the last 6 minutes. So he ran the rest of the 5 kilometers in the last 6 minutes. So he had.
Add them on each time.
So you're just following along. It's like connect the dots with the scenario, with the story that you're given. Right? Easy
So how
peasy.
was the last one 40 minutes?
Because he did a 40-minute practice. So that's what so we knew he was only going to go 5 kilometers in the 40 minutes. Now, what we don't know is, like, is he back home? I don't know. Is he waiting for someone to come pick him up 5 kilometers from his house? Who knows? Right? We don't know where his path went. We just know how long it took him to run 5 kilometers. Mia?
How long was
5 kilometers is like 3-something miles, right? Let me look it up. Kilometers to miles. .1 miles. So, it's just a leisurely little, right? 40 minutes. But he didn't run for 10 of them. So he ran 3 miles in 30 minutes. That's not terrible. All right. Let's do it again. This time we've got Sarah walking her dog after school. She has a 20-minute walk. First thing I need to do is fill out my graph. I'm going to label my X and Y axis. This time I'm increasing by 2 minutes. And then my distance is by 0.1 miles, tenths of a mile.
What's her?
Why is it 36 not like 35?
I didn't make the schedule, so I don't know.
It's hard to
Showing
say
our
exactly.
classes by
Who made it?
Mr. Ayers,
Who's Mr. Eric?
he's a math teacher down here.
Try to be exact.
I think if he does it by that, then the classes are more equal increments based on when we needed to have.
36 minutes. We have 36 minutes each class period.
Why not 35?
Just
Okay.
what she just like.
All right, let's look at Sarah's situation here. We all have our graphs filled in. In the first 4 minutes, they walked 0.2 miles. So I'm going to go over to 4 minutes, up to 0.2. And this time, it's distance from home and time. So we're looking at how far away Sarah is from home and how long she's been walking. They picked up the pace and completed 0.5 miles over the next 6 minutes. So that tells me how many total miles have they gone? 0.7, right? Because they completed this over the next 6 minutes. So they went 0.5 miles further over 6 minutes. So now I'm at 10 minutes total, and I'm up at 0.7.
Like I said, 6 minutes, not 10.
Well, she'd already gone 4, so 4 plus the new 6 gives me 10 total minutes. Almost forgot.
Non-linear, right?
Definitely, yep. Then she saw a friend that wanted to pet her dog, so she stopped for 4 minutes to chat. So she's not changing her distance. She's just chatting with a friend.
Is this all you have to do on the test?
Mm-hmm.
What?
Not terrible, right?
You did peasy.
She realized she had to go home to swim practice, so they raced home in the last 6 minutes. So she's going back home. Right? Because she has the distance from home, so she has to go back towards her home. Now we have a question that goes with the graph. How far did she actually walk her dog?
1.4
Why?
miles. Huh?
Why?
Because she went 7 up and then 7 down.
Yeah, so she went 0.7 away and then 0.7 back to her house. Great. So she walked 1.4 miles.
Wait, why did it go all the way down?
Because she's going back home. So this is her distance away from the house and then distance back to her house. Because that's what this graph is measuring this time.
We tried it all by ourselves. No.
Yeah, there's just one little word in this next one that I need to focus on before you guys start it. Okay? So here, remember it said she completed 0.5 miles over the next 6 minutes, so we added those two, right? So if you go to the next page, it says, you know, these people are riding their bikes, mountain biking team, Thomas and Jerry, okay? And it says that they increased their elevation to 400 feet. So you're not going to add these. You're just going to, that's how high they got on the mountain. Okay, so this one is just a little bit different because there's one word here. Instead of they increased for another 400 feet, this says it just went up to 400 feet. So your highest point is going to be 400 feet here. Go ahead, you guys can do this one by yourselves.
to the bathroom.
Sure.
My pencil ran out of red. Do you have an extra one I can use?
Well, we're gonna go over it.
Alright.
Yeah. You guys ready to check your work?
Yep.
Okay. How'd you do?
Yeah.
Yeah?
I got that right. I got 12 out. Oh wait, we got the answer question.
Okay, so we don't know how far they traveled because elevation does not equal distance that you've traveled, right? So if you've ever been on a hike before, it can take you like hundreds of yards to elevate maybe only 100 feet, right? So those are not going to match up. They do not equal the same thing. So no, we don't know how far they went. We just know how high up and down they went in elevation. Oftentimes when you're going up in elevation, you have to weave back and forth. You don't just go straight up, right? So your distance traveled is bigger than your elevation traveled. Yep, go on to the next page. We're going to do this one together. This is a little bit different. This is a story that's near and dear to my heart. Starbucks drive-through. Yep. What? I don't, but I love their hot chocolate and chai tea. Yeah, I have chai tea latte. Didn't I show you guys my order the other day? I did?
My stepdad, he gets a hot chai tea latte.
So good.
6 pints of chai.
Oh my gosh. What size?
Grande.
Oh man, that's a lot of chai.
I
Whew.
don't really.
I used to get the biggest one, but I never finished it, and then I got real mad that I didn't finish it, so now I get grandes. Well, sometimes talls. I don't know. Depends on the morning. So it's like a medium. So it goes like tall is their small, grande is medium, venti is large. Because they fancy.
If you get like a strawberry acai and you put it into a grande size, it fills it up. Like
'Cause of the
grande,
ice?
Like a grande with no ice.
Yeah. Yeah, they get you on the ice. And foam. That's why I say no foam, so that I get more drink. Okay, so we're looking at a documentation of the number of cars in a drive-through at Starbucks. So we have the time of day and we have the number of cars. So first thing we need to do is fill in the axes. So I'm going to turn my paper and fill this in. Twelve is PM. All right, So now we're going to look at time intervals, meaning windows of time where things might be happening. Okay, so if I'm looking at this graph and I want to find a time interval where the rate of change is constant. So that means I actually have something changing and it's a constant change. What's it going to look like? What? Not quite, but let's back up a second. What's it going to look like on the graph if I have a rate of change that is constant?
Straight line.
It's going to be a straight line. And I know what you're thinking, like, oh, look here, but is this changing at all?
No.
So that's not really a rate of change because it's not changing. Where else do we see a straight line in one of these three choices that, yep, this is going to be my constant rate of change because there's actually a change. It's increasing. So this doesn't work because there's no change. And then 2 to 4 is just a hot mess, right? That's a curved line. So that's definitely not linear.
Wait, why couldn't it be 7 to 9?
It could be. That's just not one of the choices.
Okay.
You're right. So you just have to pick from one of the choices. You don't have to tell me one on your own. You just pick from one of the three choices. Rylan, you okay back there?
Yep.
You sure?
Yep.
Okay.
Would 1 to 4 be
Correct. So for part B, which is nonlinear, that's going to be 1 to 4 because it curves. 7 to 9 is a straight line. And 9 to 1 is obviously a straight line. So this would be looking for the curve for nonlinear. All right, and then in which of these time intervals is it decreasing? We don't care if it's linear or nonlinear, just where's the number of cars on the at the drive-through decreasing? It's going to be between 2 and 3. So this is constant. And this is increasing, so those don't count. Right? So on the quiz, you're going to be asked to just pick time intervals where what you see is happening on the graph. No, you don't have to write everything. I'm just giving you guys pointers and reminders. Okay, now something a little new. We're going to talk about maximum values. What does the word maximum mean? Most, highest, right? So what ordered pair could we use? And there's several you could choose from, but pick an ordered pair that would represent the most on the graph. What do you think? Maddie?
9 a.m. till 1 p.m.
Well, that would be an interval. I'm actually looking for the ordered pair like 9:20, right? Because that would be an ordered pair right there. Or I could do 1:20. Maggie, do you have a question?
Never mind.
Okay. I could even choose 10:20, 11:20, 12:20, because those are all on that constant line right there. As long as you don't pick like 2:18, because that's not considered the highest point on the graph. What does it represent? What does the 9 stand for? What does the 20 stand for? Okay, so I would say at 9 a.m. there are 20 cars in the drive-thru. Sure. And I know that because the 9 represents the time of day, 9 a.m. And the 20, the Y value, represents the number of cars. So my X and Y values, or I could say at 1 p.m. there are 20 cars, right? As long as you choose the correct ordered pair and you explain it correctly, there's many different answers you could have. How about the minimum value? What's that going to mean?
6 a.m. to 5.
The least lowest, right? So we could have 6, 5. Or we could have
4.
4, 5.
Could we put both on the tab?
Sure can. What does the ordered pair represent? What does it mean in this situation? So what does the 6 and the 5 represent here in this ordered pair? Perfect. Yep. At 6 a.m. there are 5 cars. Or at 4 p.m. there are 5 cars. Okay, we're going to stop right there today. We will finish this up tomorrow, and then we'll do the study guide tomorrow.